All right, welcome back, everybody. Trying to get these where they're not blindingly glaring on here. What day are we on today?
September 1st.
Not date.
Day 4.
Day 4? Is this day 4? I'm glad someone understood what the hell I was saying because I was not very quick. I wrote day 21. Day 4. We're going to do 2.2 to 2.4 today. This is all graphing. Some of it's actually in 2.1, but it's all graphing.
Yay.
The computer's going to do all the graphing for you, so quit your crying. There are teachers at COS that make you do this shit by hand. So, consider Hefe a merciful God.
Thank you.
You're welcome. You're welcome. I'm glad someone appreciates that. We're going to start off by comparing bar plots to histograms. And to do that, I think the best thing we could do is just go look at them first. And so you guys get a feel for them. I did point this out as something you should do. At the end of class. And I don't know if you did or not, but we're going to go take a look right now. Bar plots versus histograms. And it's StatCrunch. It is StatCrunch website. And I'm going to look at my data. We'll do the stats project one that we were looking at the other day. So let's take a look at what options are available for bar plot. I'll write down these commands in a second for graph and bar plot and graph and histogram. Where the hell is this? 1 second. Hello? Thanks for fucking calling and hanging up. Is everyone having that happen more often lately in like the last 6 months or so? Just like a fucking random phone call and you answer and they just hang up immediately?
Yeah, you just get scammed close like some random location.
Like, are they just trying to see what? I don't even. They're not even like. I don't even know what the scam is. There we go. So I got graph of bar plot versus graph of histogram. Well, the first thing I could see is that bar plot is letting me do gender, but histogram isn't. So why is that? Let's go take a look. What's in gender? Gender has female and male. And it's letting me do response and age and shoe and height. So what's different about the gender column?
Not numbers.
They're not numbers. Is that the difference? One of the differences between bar plot and histogram? Let's check out, let's see what other columns have no numbers and check. Hair and weight, both are not numbers. So does bar plot let us do hair and weight? Yes, it does. Does histogram? It's not giving me a lot of options for histogram at all. Like, I don't have a way to select multiple ones. Bar plot, I can select them all. Here, I can only select response, age, shoe, and height. Oh, that might be because all the rest of them are, in fact, just letters, right? All the other columns don't have numbers. So that looks like one of the differences. Bar plot, we can do anything. Histogram requires numbers. We'll write that down in a second. On both of them, I can do order. I can set the order. No, I can't set order here. Interesting. Here I can change the order. Here I don't have an option for changing order. So maybe we'll look at shoe size. Thank you. This value above bar is handy for both of them. Click that and it's usually pretty handy. God damn it. Look at this. Bar plot is asking me if I want to do horizontal or vertical lines. I don't get that option over here. What happens if I do that? Oh, the horizontal lines are these little lines right here. So that's my bar plot for shoes. And that's my histogram for shoes. What else do we see as differences between these two?
I have numbers.
Well, they both have numbers.
No, I don't.
This one, you just like, you can see them on a couple of them. If I make it larger, you can see them on all of them. These things are just when I said value above bar. It was one of the check boxes. It makes it handy because then you're not looking over here and going, how fucking tall is this column? Which you can always tell if in StatCrunch, if you put your cursor over a column, it will give you information about that column. So the column I have highlighted right now is this one right here. And it's telling me there was 23 entries and this is shoe size 7.5. So what kind of differences do we see? One of them's got spaces between the bars, right? Histogram doesn't. So the bar plot has spaces between the bars, histogram doesn't. The what?
Point half like changing and the other one like 5.
Right.
There again.
This one over here doesn't look like, I don't know how big these bars are. This is actually, like over here, I had a 7.5 or 6.5, like where's that 23? Let's do the tall one. The tall one was for a shoe size 9 was 28. The one that's got a shoe size 9 is this one, and it says bracket 9, 10 parentheses. Does anyone remember what that means in mathematics? It means all the shoe sizes that start with 9 and go all the way up to 10, but don't include 10. For shoe sizes, that's 9 and 9.5. But like in numbers, regular numbers, you could go with like 9.99. We'll write this down all in a second. So like these have got different categories, but maybe I could deal with that over here. Let me try to do that. Let me show you how that works. I'm going to say, what is this first column here? This first column starts with a 3. I can address that by saying, when I say bins, I can say, it says, whoa, lots of unique number values for shoes. Want to turn on binning for this feature? And I can say, okay. And it chose its own bins. I wasn't given a choice. So this one chose to do 2 to 4, 4 to 6. Well, that's fucking confusing. Both of them say 4. Like this one right here, this says 8 to 10. This says 10 to 12. Which one does 10 go in?
10 to 12.
Are you sure?
There's 8 to 10. Yeah.
It could be 8 to 10. It doesn't really say. The other one, this one actually tells us that the bracket and the parentheses actually give us information. This one, I think you're right. I think it's the 10 to 12 one as well. That's a good intuition, which is correct. But just looking at it, it's not clear. It says 8 to 10 and 10 to 12. I also had some other options in bar plot. I could change the order. And now I could have the biggest shoe sizes first and go downward. Whereas on the histogram, I didn't have that option. There was no order button here. We'll look at doing binning in a second. I'm going to come over to writing some of this stuff down. So bar plots versus histograms and stack crunch. The commands to get to either is go to graphs and then go to bar plots. And bar plots is with data. You have two options here, with data, with summary. I don't think histogram gave us that option. No, it didn't. Histogram didn't give us that option. It just went straight graphs to histograms. Data means we have the entry from each person. With summary means someone added up all the totals before entering it in StatCrunch. Totals for each category before entering into the software.
What's that word underneath data? With data?
Summary. Kind of like in a story, like the essay thing, your summary is at the end. It's the same premise. The summary of an essay takes the entire essay and just kind of all wraps the ideas all up in one paragraph. The summary for a data table, it just takes all the data and it like condenses it down to a little bit of information. Instead of saying how many people said shoe size was 9, listing them individually, it just says this many people said shoe size 9. Okay, so they did have some commonalities. What do they have in common? And then we'll do bar plots and then we'll do histograms, like their individual, what makes them different. In common, they both showed rectangles, right? Data was in rectangle form. And they were actually both showing frequency or relative frequency. Okay, so one thing we noticed with bar plots, the boxes didn't touch. But on the histogram, boxes do touch. You guys were lucky with the 10 a.m. class. I got in here at 7:50 and Zoom started up. Anyone in class? Well, not you guys aren't lucky. You guys would have been the same way. I was able to project just fine, but I was not able to project to anyone that was staying home. And I had like eight people trying to Zoom in. And I wasn't able to get it to record properly for like 10, 15 minutes. I contacted tech help right away, but it was a little bit into class. Is anyone online right now? Yep, so someone got lucky. They were able to see this all from home. All right, so what else is different here? Well, this one required numbers. And this one could be categorical or I guess I should say qualitative or quantitative. Quantitative data, and this one was strictly quantitative. We saw on the histograms had to increase order only, increasing order. But on bar plots, we could do any order. Histograms have to go up in order and they go up sequentially. That's what in order means. Sequentially. In sequence. Now, I didn't show it here, but bar plots can be both vertical like we had here or horizontal bars. We've seen bar plots where the bars go sideways, but histograms has vertical bars only. I also didn't do it here because I just didn't. Bar graphs, you can show more than one data set. We've all seen the bar plots where they have like guy versus girl for each category. For histograms, it makes a separate graph for each group. For each data set. Everyone ready for Mark? Or does anyone need to still up because you're still writing? Okay. Three-day weekend, yay! Totally forgot. I thought it was the following week. I was telling my Monday, Wednesday class, I'll see you guys Monday. And they're like, the fuck you will. I'm like, what, y'all skipping? They're like, it's fucking Labor Day already. I'm like, really? Already? Sure, I have it on my syllabus. I have it on my calendar. I got it scheduled in. I just, in my head, it was like the following week. I like 3-day weekends. All right, so both of the bar plots and histograms had number grouping. But on the histograms, we could choose what the settings were. So we're going to talk about how they group numbers or group categories. Group numbers up on histograms. This process is called binning because it's like we make a bunch of bins. Bins or classes. The other name for it are classes, but they're like bins and we're just like throwing the data in the bins. Many of us do this for our clothing. I could have a general category called clothing, but when you start putting that shit away in your dresser, you've got a drawer for your socks and you've got a drawer for your underwear, right? Unless you don't have very many of each, where you might put the underwear and socks in the same drawer, people tend to end up having them in different drawers. Definitely no one puts their socks with their shorts unless they're fucking just a misfit. If you got your socks in your short drawer, it might be because you don't have enough socks. But in general, it's just people being lazy and just throwing shit random. So this is like throwing shit into bins. We put our socks in one bin. It's a drawer on a dresser. Underwear in another bin. Here we're doing the same thing with numbers. So last Tuesday, we looked at the age group on this. And we saw that we had a 14-year-old was the youngest and a 79-year-old was the oldest. And when we did, I'll just show it to you right now. This seems like something we could show. I do graph, histogram, and I choose age. I have spots where I can tell it what bins do, but StatCrunch will choose its own. And notice like this little box right here says 10 to 15. I'm going to write that down. I'm going to write down the numbers I see. I see bracket 10, comma 15. And then the next box shows bracket 15, comma 20. And the next box shows, if I can move my hand, I'm not left-handed, I'm trying to be lazy. Bracket 20, comma 25 parentheses. And it looks like it keeps going up by 5. We're just talking about the groups right now. So this is what I'm seeing right here. I'm seeing this pattern right here. This is actually called interval notation. And we see this in StatCrunch. In mathematics, we would say for this first group, the lowest age is 10. So 10 is less than or equal to the age, which is strictly less than 15. So this is like doing 10 all the way up to 14.999999 years old. So if you can see it, the bracket means include the number. Parentheses means don't include the number. That's handy. Because if you'll notice, 15 shows up in both groups. It shows up in the top group and it shows up in the second group. But if we know how to read it, now we know which one 15 actually goes in. 15 goes in the group where it starts with the 15, not the one where it ends with 15. So this process would continue. This one would include 15. 15 is less than or equal to age, and this would go all the way up to 20, but not included. So 15 up to 19.999. The 20 bracket up to 25 parentheses says include the 20 and go all the way up to 25, but don't include 25, which means 20 up to 24.9999. And this process keeps going. Yeah.
Can you explain it one more time, sorry?
Yeah, so like when we have a bracket and a parentheses, this means we're looking at numbers between 10 and 15. The bracket means we're going to include that number in the range. We're going to actually say 10 is a valid number here. The 15, notice how the 15 is in two groups? The one that the 15 is actually included in is the one with the bracket. The parentheses doesn't actually include the 15. So 14.9999 is just below 15. So all the way up to, but not including. Does that make sense? Okay. Thank you for asking. If you don't, if you don't understand, please say something. This is this is stupid. You know, the see something, say something. This is kind of like the opposite. If you don't see something, say something. Like if you don't get it, say something. Or if you flat out don't see it, like I haven't pushed the page up high enough yet. Yeah,
So in that case, if let's say one of the ages, the minimum age, oldest age was 30, would it move up to like 31? So comma, like parentheses, so it could be 30, but it can't be.
well, there were more groups. I just didn't write them all out. This should have gone, I should have gone all the way up because the 79 was the oldest. This should have gone all the way up to 75, 80. So it would have done each group in between. But yes, there should be a group for every single number. Which one would the 30 go in? So at some point we had a 30 thing here, a 35, and then we had some like more stuff in there. Which one should I put the 30 in? Should I put it in this one or should I put like I got a green pin and a red pin. Which one colored pin should I put a 30 in? The red. Because it's got the bracket.
Okay, let's say, there was something, because you have to end it, right? You have to end it, where the age, the last person, the oldest, right? So it's the oldest.
No, it's not ended where the last person is. It's ended where we keep the sequence going. If 76 was the oldest person, we would still have a 75 to 80. Because each of these, notice how far apart are these? 5. That actually means something. That's called the width. The width is 5. In fact, on StatCrunch, this isn't something we can enter. On StatCrunch, we can enter starting point and width. Or starting value and width.
So it doesn't matter if it's like, you have like some, like the oldest person you write about with 60, it's still the width would be 70, like 60 to like, 65?
Yes. Excellent question. Because we want to keep the bins the same size. Like, picture it like the width of a drawer. You got all your drawers in your dresser. Just because you only have like one pair of like fancy slacks, most people aren't gonna fucking put slacks in a drawer. But like you don't have like a narrow drawer on your dresser. I guess some do, but people generally do like jewelry and shit in there. But like generally drawers all have the same width. That's the same thing with these bins. Whether you fill the drawer up or you only have one item in it, the drawers need to stay the same width, just like the bins do. So the width is 5, and actually the easiest way to find it, if you're not sure how to do it, here the numbers kind of pop out at you. But what we do is to find the width. Subtract the consecutive lower class limits. And what I mean by that, I said these were bins or classes. The way we have it do it, this is the lower class limit. And then we have a comma, and I should have moved this and put it somewhere else. And then we have our upper class limit. So up here, those are the lower class limits. Consecutive just means in a row. So it doesn't matter which 2 I pick, I'm going to get 5. 15 minus 10, 20 minus 15, 25 minus 20. These all equal 5. Now, the homework is likely to show you these numbers. Homework is going to list shit like that. Why? Because they want to make sure you know the math part of how this converts to this. They could fucking show it like this interval notation. In fact, it would take up less coding on the computer software side to do this. But they want to make sure you know the difference between, or that 10, bracket 10, comma 15 parentheses means 10 to 14.99999. And I could keep adding 9. Sometimes I would. Like if we're just doing whole numbers, I'll show it in a second. Maybe I should show that now. So like if this were in thousands. And we had like 10,000 to 15,000. Like maybe we're talking about people. Maybe I should put a comment right in the correct form. That means 10,000 people up to 14,999. And I wouldn't use a decimal here because it doesn't make sense to talk about like a decimal part of a person, right? So here we would just use a whole number. This is where the word you'll see in the homework a lot. They'll give you ranges in the fucking thousands and tell you to make you write out all this shit like this. In StatCrunch, we can set it. We can choose which ones we want. Let's go take a look at StatCrunch real quick. The default one for histogram for age chose 5 and started at the year 10. I can instead go, you know what? I want bigger ages or smaller ages. Oops. Maybe I want to do every decade. I want to start at 10 and do 10 years apart. So like 10 to 20 and 20 to 30 and 30 to 40. If I do that here, now it shows 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60. So like we can pick it. Notice over here on this histogram, I have no gaps. On this histogram, I have a gap. There is no column here. It's between the 65 to 70 column and the 75 to 80 column. But if you actually put your cursor over the line, it will show you that this is a 70 to 75 column, but the frequency is 0. There's no entries. That will show up in the homework too. They'll give you a category that has a frequency of 0. You still have to type in the ranges. So let me write that down. If there's a gap in the histogram, it means the frequency is 0 for that column. Homework will still make you report it. Let's say there were no entries for 15,000. Let's say we had 15,000 up to 20,000. I guess I don't need as many comments here. The homework is but the value is 0. There's no frequency. The homework is gonna want you to actually say 15,000 up to 19,999 and enter 0 in the frequency box. This is a missing bar though. It doesn't show up on the graph. This catches a lot of people and I get a lot of emails about it. Like, I don't know what I'm doing wrong on the problem. They had clearly understood what they even had everything else right. They just didn't have the 0 row in. So make sure you include the 0 rows on the homework. How do we choose what bin widths we want? Choosing bin widths depends on the topic. Sometimes it very much matters. If we are talking about completed semester units, There's only two that are natural. Only two that are natural choices. A full-time student technically has to take 12 units. So like, that's a good choice. 12 is a good choice. However, if you want your 60 units and transfer, in 2 years, well, we have 2 semesters a year. That's a total of 4 semesters to get those 60 units. 60 divided by 4 would give us 15 units a semester. So those are logical ways to group like semester units. That way we could see like how many semesters the average student would be going through to try to get out in 2 years, or it might just be like how many are what's doing full time. Picking like 8 or 19 doesn't make much sense. Because it doesn't match up with anything. All right, you guys ready for a little bit more? I guess there's a little bit more to say in this category. If they ask you for the mid value, or the midpoint value for each group, let's take a look at our age, and the default setting on age was 10 to 15. Then we had 15 to 20. And we had 20 to 25. And we could keep going, and this went down to 75 to 80. To find the midpoint for each category, let's call it category I. Like I equals 1, I equals 2, I equals 3, going down the list. So like this is I equals 1, this is I equals 2, I equals 3. What you want to do is you take the lower class limit for I and add, I'm going to abbreviate this LL. So the lower limit for I, and we're going to add the lower limit for I plus 1. I'm going to write the LL above it. And then once we've added them up, we're going to divide by 2. This is going to be really clear when I show the numbers. For bracket 10 to, I'm off the screen. For bracket 10 to 15. Oop. Let me just put up all this shit. For this one, I'm gonna take the 10. And that's a 15. I'm gonna do 10 plus 15, and I'm gonna divide by 2. You should, if you're doing it on a calculator, make sure you hit enter between them. You want to do the 10 plus 15 first, which is 25 over 2. This would give us 12.5. When you're done, you should be able to go, yeah, that's halfway between 10 and 15. It's halfway. If it doesn't look like it's halfway, you've done fucked up. You probably didn't hit enter before you hit divide by 2. If you don't hit the enter first, if you just type in 10 plus 15 divided by 2, what you're really doing is 10 plus 15 over 2, and the 2 is only over that one. And you're going to end up with 17.5. And 17.5 is not even in 10 to 15. So it should look halfway between. So I do this for the other ones. For the 15 category, I'm going to add the 15 and the 20, divide by 2. For this one, I'm going to do 20 plus 25, divide by 2. And you'll find, once you've done the first one, the difference between each one of these should be the width that you already had. So if you just calculate the first one and just start adding the width to it, you can get all the other ones afterwards pretty quick. Because the width here was 5, adding 5 to 12.5 gives you 17.5. Adding 5 to 17.5 gives you 22.5. If you want to do pie charts, you're going to do graph, pie charts, and you're given the option of with data and with summary. This one, this is kind of like the bar plot. You can't choose bin settings. You can just choose to turn it on. We'll go look at it in a second. You can do graph, pie chart. We have data, so we're gonna use it. Let's say we do shoe size. We can tell it if we would just want to show the count or the percent of total. There's other stuff you can do, value ascending. The start angle is like how it rotates the shit, but when you're making a par track, most people don't give a shit. You can tell it to use a lot of colors or a few colors. Ew. Might be worth toying around with later. But it asked me if I want to turn on binning because there's a lot of shoe sizes here. I'll say okay. And it looks like a pie chart. It tells us the range in here, but some of these are too small. And so you got to kind of look at the colors over here. So the little blue wedge right here is the 2 to 4. There was only one person that said it. So this is the category, the frequency, and then the relative frequency. We've all seen pie charts before, right? This isn't new. This is just how you make them in StackBench really quick. Now, if you want to play with the colors, I'm kind of curious about that red to blue scale. What does that look like? How is that fucking readable?
What's my color?
But it's red to blue.
Oh, yeah,
Cold to
so it's like-
warmer.
It's like I think the lowest is like red and it's supposed to be like dark.
I understand what it's doing, but there's not a wide range of color there. Like if we had a rainbow range, like red up to purple, then you like, that's more noticeable variance here. Some of these that's a little rough. I don't know that I like that. What are the topics we got here? What's the orange scale? That's worse. That's like the gray scale. That's got to be just like the gray scale, but in gray. Colorblind say, ooh. People have problems with blue and green. Is that what's different? Nope. How is that fucking colorblind say?
This is making that feel.
How do you look at this and say the difference between 2 to 4 and 14 to 16? Like one's slightly more visible? That's fuck all that. That's all lame. Like soft colors or mixed color. What's mixed?
Mix would be good.
That's a little bit better. I got a pink zone in there, a peach. No purples. Couple greens, couple blues. Huh. So that's 2.2 and 2.1. Let's take a look at 2.3. I kind of narrowed it down to just a couple topics. I've deleted a couple topics. I just verified they're not in the homework because and I need to verify the quiz doesn't have it either. There's something called polygon charts and ogive charts that look like they say "oh give." They're a pain in the ass. They're not helpful. A lot of people don't like using them for statistics, at least. So 2.3, we have the stem and leaf plot. And we're gonna have the dot plot. So I'm just gonna give you let's say the data includes. We got 14, we got 17, 18, 18, 18, 19, 20, 22, 22, 23, 23, 23, 25, 28, 29, and let's throw Hefe in, he's got 48. Let's say that's our set of data. I like made up ages for people in this class. So this is how a stem and leaf plot works. This is what a stem and leaf plot would look like. I'm gonna have a 1. I'm gonna have a 2. I'm gonna have a 3. And I'm gonna have a 4. And I'm gonna have a big vertical line, and the 1 is gonna have a 4 next to it, a 7, 3 8s, and a 9. The 2 will have a 0, 2 2, 3 3 3, 5 8 9. The 3 won't have anything on it, and the 4 will have an 8.
You just add numbers randomly or do you get them from somewhere?
I didn't add, I just created numbers randomly.
Oh, so those are random.
Those are just random numbers.
I thought you might have taken it from the data included.
No, these are randomly generated by Hefe.
Okay.
I more want to illustrate what's going on with the stem and leaf plot. What does it look like I'm doing?
In the last digit from each number.
We're taking the last digit from each number and we're putting it on the right? And we're grouping it up by first digit. That's your stem and leaf plot. It's that simple. First digit, well, I'm gonna say first digits. And then on the right is always just a single digit. Because if like you're in the hundreds range, you might like 110, you might put 11 over here and a 0 over here. So you might have more numbers on the left. Now, if you have too many numbers, the computer will sometimes split it up. Like there's a lot of numbers for the 2, so I might want to say 1's going to stay the same, 4 is going to stay the same, but I'm going to do 0, 2, 2, 3, 3, 3, and then 5, 8, 9 like this. Kind of like the way you would round. For long rows, they'll break it up into smaller parts. So you can't just look at the first row and go, those are my only 20-year-old ranges. Got to make sure that the next one doesn't start with a 2 also. That's pretty fucking easy, isn't it? Pretty straightforward. Guess how we get to this in StatCrunch? What's been the pattern so far? We do graphs and then stem and leaf. We'll look at it in a second. I want to talk about the pros and cons of it first. People are still writing down. Let me give everybody a little bit more longer. So what are some of the pros and cons? So I consider a pro. It bundles up data like the bar plot and histogram without losing, without loss of raw data. I can always get the entire raw data table back or the set of data just by pulling apart this graph. On a histogram, I can't. If it says frequency of 28 and it's a range of 20 to 29-year-olds, I don't know how many are 20. I don't know how many are 22. But on a stem and leaf, I can easily see how many of each. While still looking at the length of the rows and going, okay, the 20-year-olds were the most. 20-year-olds had the biggest group on this list. So I can still, it's kind of like if I turned it sideways, it's starting to look like a bar plot, but with numbers. So it kind of looks like a graph. Data that has decimals. Can also be retained. Can be kept. We could do 11.1 and 11.4 as 11 point and then do the line and then write 1 for it. I could still do that. And that way I still have the data. So like it even keeps continuous data. The cons are if I want the frequencies, I actually have to count them. Or relative frequency, I have to count it. And this really sucks for large data sets. I have 213 entries on my graph, or on my table on StatCrunch right now, which means I'm going to have to write out 213 fucking values. And for like age, there's like 40 of them in the 20-year-old range. So I'm just like, I'm going to have like 0, 0, 0, 0, 0, 0, 0, 0. Like it gets to the point where even counting like the 20-year-olds or 18-year-olds is hard to visually do. As I'll show you, like it's like when you see like a whole bunch of like zeros in a row, how fucking easy is it to figure out how many zeros that is? You literally have to go one at a time, like. If we had 0.00009, like figuring out how many decimal places this is a bitch. You almost need to like make little breakup marks and mark them. And that way it makes it a little easier to count. Like I can go, okay, this is 3, 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 this is 1. So there's 16 there. Trying to count those without seeing that and going, that's 15 zeros visually by hand, even if you're putting your finger over it, if it's on the screen, this is a pain in the ass to do. And so stem and leaf problems have that stem and leaf plots have that problem. Usually it's just gonna be really hard to count. Dot plots. They look just like bar plots. But instead of rectangles. They are stacks of dots. So for that last data set we did. Like I had 10 to 19-year-olds, 20 to 29-year-olds, 30 to 39-year-olds, 40 to 49-year-olds. I would put 6 dots right here because there were 6 entries. There were 9 entries for the 20 to 29. And there was only 1 entry for the 40 to 49. You still get the same feel for it that you would with a bar plot. This is where you would use this usually is if you're working in groups with a lot of groups or individuals. And you ask them to go put their dot in a column. So look, if I put these age categories up there on the board, and I just said everybody one at a time go up and put a dot in the column that you belong in. So it kind of makes it easier to collect data from people. But then you still gotta like assemble it. And here to do this one, we go graphs and dot plot. So I'm gonna go just like show you some. We can do a graph, we can do a stem and leaf plot. Let's do it on shoe. No, let's do it on age. I'm gonna say compute. And it's actually telling us decimal point is 1 digit to the right of the colon. How is this decimal point? There's a 14-year-old, that is not a decimal point. I don't know what they're talking about. Oh, I don't know what they're meaning. Maybe they mean like this is a 5, this is a 5. It's not like 0.55, 0.66 or shit like that. Look at that fucking, the way they broke down the ones. Look, take a look at that. 4. So we've got our 10 to 14-year-olds. And then we've got our 15 to 19-year-olds. So they split it in half, round up or round down. Try counting those fucking numbers, Bates. You see it, like, see how this is, it's valuable because it keeps all the data. I can still look at it and go, oh shit. The 19 and under range is the biggest group. I can see it looking at it right away. It's the longest row. Well, maybe if I squeeze these 20s up here, if I put them up here, it's gonna be pretty long. But it still looks like that range is the longest. And it goes through and does it. Oh, look, fucking poor 79. Poor 79, they didn't give a motherfucking row to. What is this bullshit? 79 is an outlier. We'll talk about outliers more later on. But that's what they're doing here. Outlier trimming. Anything that just like stands out well outside the normal. The next lowest age was a 65. So like there's a big time gap between 65 and 79. So they're trimming out the 79. What does mild and extreme do? How much trimming do they do there?
Oh, wow.
Oh, they go poor 57-year-old. Why don't they trim the 14? I guess that's really close to the 15. And I guess the 57 is a bigger distance from the 52. So we still get a feel for what's going on. Look at this same thing with the dot plot. Before I do that, look, we have no other options here. Well, what does this leave you in? Oh, look at this. That's confusing to read. Better off to leave it at 1. Let's look at that same graph with dot plot. They allow us to pick the size of our dots. More dots. Okay, so, ew, it says up to 2 values per dot. Well, that's fucked up. That's not good. Is it 1 or is it 2? Like it better be like 2 all the way up, and maybe the top dot's not 2. On this, like, look at try fucking counting this fucking dot. Like if they're too fucking close together, like counting the dots isn't easy. Now, one kind of cool thing about it is, like I put my cursor over this dot. This is for shoe size 9, and this dot is showing me it's counting row 165. And there's one other row in it, which isn't listed, but it's probably, oh, wow. Are they not in order? They are in order, but the fucking low numbers are at the top. Weird. So 165, and then the next one is 169. So the one with the 165 is probably 166, 167, 168. They didn't show which one. The top dot is not the +1. It's the fucking. So if there's only 1, it just doesn't say +1. Do any of these have that? Like. Okay, so when like this column right here, column 12, the dot on the top is the one that only has 1. But this is still kind of fucking hard to read, right? The histogram gives you all the shit in a plot. You get the data that you really kind of want out of it. The stem and leaf plot, I think, is the second most useful one, because I can, like, if I really need it, I can pull the data right back out of it. And I can still see it organized in like a chart format. All right, a little bit more. I'm bringing this up because it's going to come up next week. There are 4 major distributions of charts. And I'm just showing you in them, and I'm telling you their names for now. We'll talk about more what they're good for next week. These are all gonna be related off histograms. Something like this, where all the columns are about the same height. This is called a uniform distribution. Like, we all know what a uniform is. It's like what like police officers wear, or nurses wear, or firefighters wear. The key thing about uniforms is they all look the same. On a graph, a uniform distribution, the boxes are all about the same. Notice that they're not equal, like I have them staggered a little bit. The next one kind of looks like our age category. Where the columns on the left are taller. This is gonna make you angrier than shit. This is called skewed right. Well, not maybe angry, but like confused. Types of things you'll see in this category are like housing prices, income, family income, number of children, number of cars. Most families only have 1 or 2 cars, maybe 0. Every once in a while, come across somebody who's got like fucking 8 cars, and you're like, the fuck do you need 8 cars for? Right? They might have 8 kids. The uniform one, you'll see this. This is like when you're working, playing with dice. Or cards, like the suits in a deck of cards. We have our other skew graph. Our other skew graph has the tall columns on the right. And of course, this one is called skewed left. Because that's how statisticians roll. Things in this category are like GPA at graduation. This is the, like, at graduation is the important part. People with low GPAs tend to not graduate. You got a 1.5, you're getting like averaging, or you're getting C's and D's. You give up. You eventually, a lot of them give up. They don't finish. So you get a lot of like threes, 3.2, 3.4. You'll get a few that are 4.0 and very far right, but not very many. Most of them are like in the threes. Also, age at death. It's a little morbid. But most people live a long time and die in their old age. There are some people that die in their middle age and teenage years. Unfortunately, there are people like children, like infant mortality. There are deaths, but thankfully they're a lot lower than like old fuckers like me. I'm an old fucker. Not that old yet, but most of you will go, he's an old fucker. It's fun. 18-year-olds think like 29-year-olds are fucking old. And I'm like, oh, to be fucking 29 again. I would fucking love to be 29 again. I don't want to be 18 again. 18, when I was 18, I was dumb as shit. I thought I knew everything, and I didn't. Like, you haven't learned a lot of life's lessons at 18. You graduate high school, you still don't know shit. Go work for fucking 5 or 6 years, start paying your bills, learn what it's like to take care of yourself after you have a rent payment, car insurance payment. All of a sudden, you learn a lot of shit in those extra 6 years that you didn't know when you were 17, 18. So to go back to 29 would be great. Then we have the most, not perfect, but the most desirable one, where the tallest graphs are, or tallest columns are near the center. This is called bell-shaped. Or the simple reason is like if I drew the shape of a bell over it, it would look like the heights of the columns. Bell-shaped. A lot of type of things that fall in this category, like height, weight, shoe size, IQ, every category has people that are really low and people that are really high, but most people are somewhere near the middle. If you start breaking it down by country, now we start noticing differences, like weight. Americans there are more Americans on the heavy side than, say, in Italy. That's 2.3. The next part, 2.4, I can point out to you in 10 minutes. We're going to be done early. This is exciting. I didn't think we were going to be done early, but we're going to be done early. Everybody likes to be done early, right? Not my evening class. Well, some of my evening class. My evening class, half the class will stick around afterwards and like work on homework. Never ask me a goddamn thing. They're just like, they like having the safety net as a teacher. You guys, whenever we finish class early, you're always free to work on homework in class in here until the bell rings. Let's come over here and take a look at 2.4. Is everyone done with the screen? Okay. So where I'm going to go for 2.4, I'm coming over here and we're in our class. If you click on files, I'm going to use this a lot throughout the semester. So it might be worth something to grab. It says Math 21 lecture notes in class. I tend to pull this up every once in a while and use it because it's got good stuff already written down. So I've already downloaded it and I've got 2.4 right here. The 2.4 is on graphical misrepresentations of data. How do we get misled or confused by graphs that are constructed poorly that don't really show what the data is showing? Here's an example. The table on the right actually has the information. So this is representing life expectancy every decade from 1950 up to the 2000 to 2010. So 1950 was 68.2 years, 1960 is 69.7. And up to 2000, it's up to 77. We've gained like maybe 9 years life expectancy over 60-year period. Not bad. Look at the chart. Here is 1950 and here is 2000. Does this look like it only went up 9 years? The graph makes it look like life expectancy is fucking skyrocketed in the last 60 years, 70 years, like phenomenally. The problem is, and it's a little hard to see. Look at those numbers on the left. It doesn't start at 0. It starts at 68. So, I'm going to show you a better way to have it. So the real chart would look something like this for the life expectancy. The real chart is not the desired one, but we would have something like we'd have 10, 20, 30, 40, 50, 60, 70, 80. That's 60, that's 70, that's 80. So like 1950 is here. And we're going up to 2000. And I'm just going to put in dots. 1950 was up to 68.2. It's up here like this. And like 60, 70, 80, 90. 1960 is still below 70. So it's like right there. 1970 is right above 70. So it's right there. 1980's got a little bit bigger of a jump. I should say 80, not 88. 1990 is a little bit bigger, and 2000 is almost at 80. So it should look like this. Now, we don't like this on paper because there's a lot of white space here. And too much white is undesirable. It's a waste of paper. It's a waste of what you're working, the area you're working with. So a better way of doing it, the way they had it, is doing something like this. And now we can have that thing that has sharp increases. But this is like 68. And up here, like we can do like 70. And we'll go up to 80. We'll have like blocks in between these going up. But having this little zigzag, it brings attention to the graph. It brings eyes and attention to the chart, to the setup. And you're more likely to notice that it starts at 68. I still don't know that it's great, because when it really is showing a very slow increase, this makes it look like a strong increase, but it will point out that it's exaggerated. Helpful, right? Because I guarantee when you're looking at that other chart, you don't see the 68. Unless you're really looking at really looking at it. Most people just look at the line. and they don't look at the numbers. One more problem in graphical misrepresentations. Want to give people another second to write this shit down though? Yay for 3-day weekend. Actually, before I show the next part, I want to tell you guys something. On Mondays, since we are having a holiday, and it's not because we're having a holiday. We've gone over a bunch of stuff at this point, a couple chapters. If you would like to meet with me over the weekend, like a Starbucks or something, I am willing to meet at the Starbucks, and I'll put out an announcement for this. The Tulare ones aren't that big. I tend to like the Visalia Starbucks on Caldwell and Demery. So I'm gonna think of, oh, fucking blurb right here real quick. Starbucks on Caldwell and Demery. Normally I'll offer it on Sunday mornings, but since we got a 3-day weekend, I'll offer it Monday morning. I'm willing to meet there from 8 to 10 a.m. But I'm not going if no one emails me or texts me.
Never gone for once and I said, oh, I'm gonna be there and they never show up.
Very rarely. No one emails or texts me. Or Discord. To let me know. So if you want to go to it, this is like the Tahoe Joe's parking lot, the Winco parking lot. I think it's Winco. Foodsco, Winsco, no, Foodsco's in Tulare. It's the Winco parking lot. There's a Starbucks in there. It's over right in front of Tahoe Joe's. That's my spot. Many of them know me by name. I'm like Norm at Cheers for anybody that's seen the Cheers show. But if you want me to meet you, let me know. If you don't, if you're happy going through this shit without help, you don't have to show up. This is all optional. All right, let's go take a look at the last little misrepresentation. "3D graphs. Look at this pie chart. Looking at this pie chart, this wedge right here close to us looks like the biggest by far, doesn't it?
Yeah.
By a long shot. That color is this like beigeish one, which is 6 to 10, which is 0.25. 11 to 15 is the purple. It's 0.23. It's almost as big. But it sure as hell doesn't look like it. 3D charts, when they're tipped at an angle, they kind of have to be tipped at an angle. 3D charts make the side that's closest to you look like it has a bigger representation than it really does. And some people will do this deliberately, put the side they want to drag your eyes to on the bottom, where it's closest to you. They want you to see that because a lot of people just like look at the categories and don't look at the data over like the actual numbers. This looks a lot bigger. And I would go like 6 to 10 is way bigger than anything else. It's visually taking up a lot more of the screen. So 3D charts, while they're fun, fucking suck. They just suck. If it's barely tipped a little bit, that's okay. Barely tipped makes it so it doesn't stand, like, make it too bad. This is really tipped though. This is like, instead of looking at like slide angles, almost like looking at the surface of something. And it really skews it, really throws it off. So don't do 3D charts, they're bad. Try not to misrepresent your data when you're presenting data in a graph, okay? That's it for today. If you'd like to keep working on your homework, you can. Otherwise, you're free to GTFO. And I will see you on, what day is it? Thursday. I'll see you on Tuesday. You guys don't get the class off on Tuesday.